Hello, everyone. I'm Dr. Yende. What if I told you that one of the most powerful anti-aging tools for your brain isn't a drug, a supplement, a stem cell treatment, or even exercise? It's sleep, more specifically, deep sleep. And what if I told you that scientists are now exploring whether carefully timed sound frequencies could help enhance deep sleep and potentially support healthier brain aging? It sounds like science fiction, but it isn't. Today, we're diving into one of the most fascinating frontiers in neuroscience, neural entrainment, the science of synchronizing brain activity using sound, and how this emerging technology may help restore the deep sleep architecture that naturally declines as we age. The aging brain has a sleep problem. When most people think about aging, they think about wrinkles, gray hair, reduced energy, or slower recovery. But one of the earliest signs of brain aging happens while you're asleep, specifically during deep sleep. Deep sleep, also known as slow-wave sleep, is the stage of sleep associated with physical recovery, memory consolidation, immune regulation, brain detoxification, hormonal repair, cellular restoration, and long-term neurological health. Unfortunately, deep sleep begins declining surprisingly early. By middle age, many people are already producing significantly less deep sleep than they did in their 20s, and this decline may have serious consequences for brain health. Why deep sleep is the brain's night shift? Think of deep sleep as the brain's maintenance department. During deep sleep, billions of neurons begin firing in highly synchronized patterns. Large, slow waves sweep across the brain. These are known as delta waves. Delta waves are among the slowest brain rhythms we produce, and they are critically important. During this phase, the brain carries out essential housekeeping functions. Waste products are removed. Memories are organized. Neural connections are strengthened. The nervous system recalibrates. In many ways, deep sleep is when the brain repairs itself. The glymphatic system. One of the most remarkable discoveries in neuroscience over the past decade involves something called the glymphatic system. Think of it as the brain's cleaning system. During deep sleep, cerebrospinal fluid flows through brain tissue more efficiently, helping remove metabolic waste products, including proteins associated with neurodegenerative diseases. Research suggests this nightly cleaning process may play an important role in maintaining long-term brain health. Less deep sleep may mean less cleaning, and over decades, that could matter. What is neural entrainment? Now let's explore the fascinating concept of neural entrainment. The brain operates through electrical activity. Billions of neurons communicate using rhythmic electrical signals. These rhythms are often called brain waves. Different brain states are associated with different frequencies: alertness, relaxation, meditation, dreaming, and deep sleep. Neural entrainment refers to the process of influencing these rhythms using external stimuli. The brain naturally synchronizes to certain repeating signals: light, sound, rhythm, music, and even breathing. This synchronization phenomenon is called entrainment. The science of sound and the brain. Have you ever noticed your foot tapping to music, or found yourself unconsciously matching someone else's walking pace? That is entrainment. The nervous system naturally syncs with rhythmic inputs. Researchers began asking an intriguing question. If the brain can synchronize with external rhythms, could sound frequencies help strengthen deep sleep activity? Could sound enhance delta waves? Could we encourage the aging brain to produce more restorative sleep? That question has inspired an entire area of neuroscience research. Targeting delta waves. Scientists have discovered something remarkable. When specific low-frequency sounds are delivered during deep sleep, precisely timed with the brain's natural slow waves, the amplitude of those waves can increase. In simple terms, the brain's deep sleep signals become stronger. The sound isn't waking the person. It isn't blasting music into the bedroom. The stimulation is subtle, carefully timed, almost like gently pushing a child on a swing at exactly the right moment. The goal is not to force sleep. The goal is to amplify what the brain is already trying to do. Why this matters for aging: as we age, slow-wave activity declines. Deep sleep becomes lighter, more fragmented, and less restorative. Researchers suspect that strengthening slow-wave sleep may help preserve important aspects of brain function, including memory, learning, attention, cognitive resilience, and possibly even protection against age-related neurological decline. This is why neural entrainment has generated so much excitement. It represents a non-invasive approach: no drugs, no surgery, no injections, just carefully timed acoustic stimulation. The memory connection. One of the most consistent findings in sleep research involves memory consolidation. During deep sleep, the brain transfers information from temporary storage areas into more stable, long-term memory networks. Think of it as saving files from a temporary folder into permanent storage. Without sufficient deep sleep, this process becomes less efficient. That's one reason poor sleep is associated with forgetfulness, reduced concentration, slower learning, and mental fatigue. If neural entrainment can enhance deep sleep, it may indirectly support memory performance as well. Can sound reverse brain aging. Now we have to be careful. Reverse brain aging makes for a great headline. But science is rarely that simple. Current evidence suggests neural entrainment may improve certain physiological markers associated with healthy brain function. It may strengthen deep sleep, it may enhance memory consolidation, it may support cognitive performance, but no study has shown that sound alone can completely reverse biological brain aging. The real story is more nuanced, and perhaps even more exciting. We may be learning how to optimize the brain's natural repair systems rather than trying to replace them. The role of to understand this technology, we need to talk about EEG, electroencephalography. EEG measures the electrical activity produced by the brain. Researchers use EEG to identify when a person enters deep sleep. Modern systems can detect slow-wave activity in real time. Once deep sleep is detected, carefully timed sound pulses can be delivered at precisely the right moment. That is what makes neural entrainment possible. It's not random sound. It's personalized timing. A conversation between technology and the sleeping brain. The wearable revolution. Historically, EEG required laboratory equipment, large machines, sleep centers, and technical specialists, but that is changing rapidly. Wearable technologies are becoming more sophisticated. Headbands, sleep trackers, smart devices, and AI-powered monitoring systems. Future consumer devices may eventually combine sleep tracking, brainwave monitoring, acoustic stimulation, artificial intelligence, and personalized optimization algorithms. Imagine a system that understands your sleep architecture and gently supports deep sleep throughout the night. That future may not be far away. The limitations. Of course, we have to avoid the hype. Not every sound frequency advertised online is supported by science. Many products make extraordinary claims with very little evidence. The research supporting neural entrainment is promising, but it remains an evolving field. Deep sleep enhancement should be viewed as one component of brain health, not a replacement for exercise, nutrition, stress management, social connection, mental stimulation, and consistent sleep habits. Technology works best when it sits on a healthy foundation. The OXYZEN perspective. At OXYZEN Health Intelligence, we see neural entrainment as part of a larger shift. Healthcare is moving from treatment to optimization, from reacting to disease to supporting resilience. The future may involve continuous monitoring of sleep quality, recovery, heart rate variability, stress patterns, brain function, and biological age. Artificial intelligence may help identify opportunities to improve these systems long before symptoms appear, because longevity is not merely about living longer. It is about preserving function, preserving cognition, and preserving quality of life, and sleep sits at the center of that mission. Final thought. For centuries, sleep was viewed as passive, a period when nothing happened. Modern neuroscience has completely overturned that belief. Sleep is one of the most active biological processes in the human body. The brain cleans itself, repairs itself, reorganizes itself, strengthens itself. And perhaps now, through neural entrainment, we are beginning to learn how to support those processes even more effectively. The future of brain health may not depend on doing more, it may depend on sleeping better, and understanding the rhythms that have always guided the human brain. I'm Dr. Yende, and this is OXYZEN Health Intelligence, helping you decode your biology one insight at a time. Thank you for listening.